Now let us solve all the problems given in exercise 4.6. So problem 1 to 5, we need to examine the consistency of the given equations. So here I have two equations. So let me write it in the form of Ax equal to B. So where A is a 2 cross 2 matrix with the coefficients of x and y, right? So I have coefficient of x is 1, y is 2, x is 2, y is 3, and then the unknowns x, y equal to matrix B, which is 2, 3. Okay, so here we don't have to find the value of x and y, we need to check for its consistency. Now how do I find x and y? If I take this matrix to the other side, that means I need to find its inverse. So the inverse of this matrix A multiplied with B would give me xy. So therefore the inverse should exist. Now xy is A inverse into B, right? So A inverse is nothing but adjoint A divided by determinant A into B. Now for the system to be consistent, the value of determinant A should not be equal to 0. If this is not equal to 0, then we can say that the equations are consistent, right? But if A is equal to 0, then I get adjoint A into B divided by 0, and if adjoint A into B is not equal to 0, right? So for these two conditions, then of course the system is inconsistent. So what do you mean by inconsistent? That means there is no solution. There are no values of x and y which satisfy the given set of equations, right? So since problem 1 to 5, here we just need to examine the consistency. We need to check if determinant A is equal to 0 or is not equal to 0 here. If it is not equal to 0, I say that it is consistent. If it is equal to 0, then I check if adjoint A into B is not equal to 0, then if these two conditions are satisfied, then the system is inconsistent. So now let us find the value of the determinant of A. So determinant A here is 1 into 3. So determinant A is 3 minus 4, which is equal to minus 1, and definitely not equal to 0. So therefore the system is consistent. So next, let's take the second problem. So I have 2x minus y equal to 5, x plus y equal to 4. So expressing it as ax equal to b, I have coefficients of x 2, y is minus 1, 1, 1, x and y equal to 5 and 4. So find out determinant A. It is 2 plus 1, which is 3. So which is not equal to 0. So therefore the system is consistent. That means the solution exists. Next 3. So we have x plus 3y equal to 5, and then 2x plus 6y equal to 8. So again, writing the set of equations in the form ax equal to b, I have 1, 3, 2, 6 and x and y equal to 5 and 8, right? So find the determinant of this matrix. So I have 6 minus 6 equal to 0. So now 6 minus 6 is equal to 0. So now we cannot just conclude that the system is inconsistent. We need to find out adjoint A into B, right? So what is adjoint A? Interchange the principal diagonal elements. So this is only for a 2 cross 2 matrix. We can directly find the adjoint A. Interchange the principal diagonal elements. So I get 6 and 1 and negate the other elements, minus 2, minus 3, right? So this into B, which is 5, 8. So what do we get? So we have 6 into 5 is 30 minus 24. So 30 minus 24 is 6, and here you have minus 10 plus 8 equal to minus 2, which is definitely not equal to 0. Okay, so we have these two conditions, both the conditions are satisfied, so therefore the system is inconsistent. So what do you mean by inconsistent? There is no solution, right? So we cannot find any value of x and y which satisfies both the equations here. So next 4, x plus y plus z equal to 1, 2x plus 3y plus 2z equal to 2, and ax plus ay plus 2az equal to 4. Okay, so let's find the determinant directly. So I have 1, 1, 1, 2, 3, 2, a, 2a. So here you have 1 into 6a minus 2a. Next we have minus 1 into these two, multiply these two, which is 4a minus 2a. Then I have plus 1 into, multiply these two, 2a minus 3a. So here we get 4a, we get minus 2a, and here we get minus a, which is equal to a, and this is not equal to 0. So since the value of the determinant is not equal to 0, we conclude that the system is consistent. So given a set of 3 equations, let me find the determinant. So I have 3 minus 1 minus 2, 0, 2 minus 1, and then 3 minus 5, and then 0 here. So the determinant is 3 into 2 into 0, 0 minus 5. Minus of minus 1 is plus 1. So here I have 0 minus 3 into minus 1, which gives me plus 3, minus 2 into 0 minus 6. So this is minus 15 plus 3. So here I get plus 12, which is 0. So determinant A is equal to 0. So therefore we need to verify adjoint A into matrix B. So matrix B is 2 minus 1, 3. So now let us first find the adjoint. So to find the adjoint, let us find the cofactors. So what is A11? A11 is leaving the first row and first column, 2 into 0 minus of minus 5 into minus 1, so we get minus 5. So I hope you do remember the signs to write the cofactors. So this is plus, minus, plus. So I have A12 equals, so leaving the first row and the second column I get 0, minus 3 into minus 1 with a minus sign of course, so I get minus 3, and then A13 is leaving the first row and the third column I get 0, minus 6 with a plus sign, so it is minus 6. Next we have A21. So what is A21? The first column and the second row, so I get 0. So I have minus of minus 5 into minus 2 is plus 10 with a negative sign, but I have a minus sign here again, right? So it becomes plus 10. Next A22 equals, leaving the second column and the second row I get 0, minus of 3 into minus 2, which is 6. So I have plus 6 here. Next we have A23, which is 3 into minus 5 is minus 15, and then you have minus 3 into minus 1, which is plus 3. So minus 15 plus 3 is minus 12, but I have a negative sign here. Minus of minus 12 is plus 12. Next, A31, leaving the third row and the first column, I have 1. So let me write 1 plus 4, which gives me 5. Next, A32 is leaving the third row and the second column. So we get minus 3 and then plus 0 with a negative sign. So it is plus 3. Next, A33 is 6 minus 0, which is 6 itself. Okay, so to write adjoint A, we have to write all these cofactors and then take the transpose. So I will get A11, A12, A13, A21, A22, A23. So write all of them column wise. So I'll directly write. So I have minus 5, minus 3, minus 6. Then you have 10, 6, 12, 5, 3 and 6. So this has to be multiplied with B, which is 2, minus 1 and 3. So what do we get? We get minus 10 plus 15. So we get minus 5. And next we have minus 6 plus 9, which gives me minus 3. And then we have minus 12 plus 18. So that gives us again minus 6, which is not equal to 0. So we have two conditions here. Determinant A is equal to 0 and adjoint A into B. So this is adjoint A into B is definitely not equal to 0. So therefore the system is inconsistent. So the next problem, problem 6, we also need to find whether the system is consistent. So find the determinant, so which is 5 minus 1, 4, 2, 3, 5, and then 5 minus 2, 6. Find the determinant value. So which is 5 into 3 into 6 is 18 plus 10. Minus of minus 1 is plus 1. So I get 12 minus 25 plus 4 into minus 4 minus 15 is minus 19. So we get 140 minus 13 and then we have minus 76, which is 51, which is definitely not equal to 0. Right? So since determinant A is not equal to 0, it's not equal to 0, so therefore system is consistent. Right? So the next problem we need to solve. So we need to solve for x and y. So writing it in the form ax equal to b. So I have coefficients of x, that is 5 and 7, coefficients of y is 2 and 3, into x, y equals 4 and 5. So xy is nothing but A inverse into B. So to find the inverse, I need to find the value of the determinant, which is 15 minus 14 equal to 1. Okay, so therefore we have xy equals adjoint A divided by determinant into B. So what is adjoint A? For a 2 cross 2 matrix, interchange the principal diagonal elements, which is 3, 5, negate the other elements, into determinant A is of course 1, into 4, 5. Right? So I get 3 into 4, which is 12, minus 10 is 2, and then we have 7 into 4, which is minus 28 plus 25, which is minus 3. So the value of x is 2 and value of y is minus 3. So again the next problem, find the solution. So we have 2 minus 1, 3, 4, into x, y, and that is equal to minus 2 and 3. Right? So xy is adjoint A into B divided by determinant A. So what is adjoint A? Adjoint A is interchange these two, 4, 2, negate the other elements. So I get minus 3 and 1 divided by the determinant. Determinant is 2 into 4, which is 8, and then minus of 3 into minus 1. So 8 plus 3 is 11. So divided by 11 into minus 2 and 3. So what do I get? So I get minus 8 plus 3, which is 5. So I get minus 5 here, and then you have 6 plus 6, which is 12, into 1 by 11. So x is minus 5 by 11, y is 12 by 11. The next problem, 9. 4x minus 3y equals 3, and then 3x minus 5y equals 7. So again, what is xy? So let me directly write, it's adjoint A. So interchange these two elements. So let me write it directly. Minus 4, minus 5 and 4. I am interchanging these two and negate these two. So I get minus 3 and plus 3 there. And then find the determinant value. So what is the determinant value? It is 4 into minus 5, which is minus 20, minus of minus 3 into 3. So minus 20 plus 9, which gives me minus 11. So 1 by minus 11. So determinant A is minus 11 into 3 and 7. Right? So how much do I get? So this is minus 15 plus 21. So I get 6. And then you have minus 9 plus 28. So minus 9 plus 28 is 90 into 1 by 11 with a negative sign. Okay. So therefore the value of x is minus 6 by 11. So the next set of equations, 5x plus 2y equal to 3, 3x plus 2y equal to 5. So we need to find the solution. So xy is nothing but adjoint of A into B divided by determinant A. Right? So what is adjoint A? Adjoint A is, let me directly do it. So interchange these two elements, 2 and 5, and negate the other elements, which is minus 3 and minus 2. Determinant A is 5 into 2, which is 10, minus 3 into 2, which is 6. So it is 10 minus 6, which is 1 by 4, into 3, 5. So we have 2 into 3 is 6. 6 minus 10, which is minus 4. And then minus 3 into 3 is minus 9 plus 25. So minus 9 plus 25 is 16 into 1 by 4. So we get minus 1 and 4. So x is minus 1 and y is 4. So moving on with the next problem. 2x plus y plus z equal to 1. X minus 2y minus z equal to 3 by 2. And 3y minus 5z equal to 9. So first let me find the determinant. So I have 2, 1, 1, 1 minus 2 minus 1, 0, 3 minus 5. So to find determinant of A, so A happens to be a matrix having with the coefficients of x, y and z. So determinant A is 2 into minus 2 into minus 5 is 10 plus 3 minus 1 into minus 5 plus 0 I have, then plus 1 into 3, right? So we get 13 into 2 is 26 plus 5 plus 3. So 26 plus 8 gives us 34. So next we need to find the adjoint of A. So to find the adjoint of A, we need to find the cofactors of matrix A. So what is A11? So of course let us write the signs to find the cofactors. So this is going to be plus minus plus, minus plus minus, plus minus plus. So this is for an easy reference. Instead of multiplying each of them by minus 1 whole power I plus j. So to find the cofactors, we have A11. Leaving the first row and the first column, it is 2 minus 2 into minus 5, which is 10, plus 3, which is 13. So that gives us 13. Next, A12 is leaving the first row and the second column. 1 into minus 5 is minus 5, and I have a minus sign here, so which gives me plus 5. Next, A13 is leaving the first row and the third column. We have 1 into 3, which is 3 minus 0, so 3. Next, A21, leaving the second row and the first column. 1 into minus 5 is minus 5, minus 3 is minus 8, but with the negative sign, so we get plus 8. Next, A22, leaving the second row and the second column. So we have 2 into minus 5, which is minus 10, with a plus sign, so I have minus 10. Then A23 is leaving the second row and the third column. So 2 into 3 is 6. So 6 with a minus sign here. Next, A31, leaving the third row and the first column, I get minus 1 plus 2. So it is 1. Next, A32 is leaving the third row and the second column, minus 2 minus 1, which is minus 3, with a negative sign, so I get plus 3. And then A33 is 2 into minus 2, which is minus 4, minus 1 is minus 5, so I have minus 5. Right? So let me straight away write adjoint A, wherein I write A11, A12, A13 column wise. So we have 13, 5, 3, 8, minus 10, minus 6, 1, 3, minus 5. Right? And then I have 1 by determinant A, which is 1 by 34, multiplied with B, 1, 3 by 2 and 9. Right? So we know that x, y, z is equal to adjoint A into B divided by determinant A. So let us not rewrite the formula again and again, it is here. So we finally get 1 by 2 and minus 3 by 2. Right? So multiplying these two matrices and dividing it by 34, we get x, y and z is 1, 1 by 2 and minus 3 by 2. So next 12, 1. X minus y plus z equal to 4. Next 2x plus y minus 3z equal to 0. X plus y plus z equal to 2. So let's find determinant A. So determinant A is 1 minus 1, 1, 2, 1 minus 3, 1, 1, 1. So let's find the value of determinant, which is 1 into 1 plus 3, which is 4, plus 1. So minus of minus 1 is plus 1, 2 plus 3, which is 5, plus 1 into 2 minus 1 is 1. So I get 10. Right? So again we need adjoint A. So determinant A of course is 10. So let's find adjoint A. So let's find the cofactors. A11 is leaving again the first column and the first row 1. Minus of minus 3 is plus 3, so we get 4. A12 is, it is 2 into 1 minus of minus 3, which is 5, of course with a negative sign, so I get minus 5. And then A13 is 2 minus 1 is 1. So again let me write the signs. Plus minus plus, minus plus minus, plus minus plus. So that's the reason why I have written minus sign here. Next A21 is the second row and first column. So I get minus 1, which is minus 2 into minus 1, which is 2. A22 equals, so 1 into 1 minus 1 into 1 is 0. Next A23 equals, leaving the second row and the third column, 1 into plus 1, which is 2 with a negative sign, minus 2. Next A31, so third row and first column, so I get 3 minus 1 is 2. Next A32 is third row and second column, so I get minus 3, minus 2 is minus 5 into minus sign, which is plus 5, and then A33 is 1 plus 2, which is 3. So writing these cofactors column wise, so we get 4 minus 5 1, 2 0 minus 2, and then 2 5 3. So x, y and z is equal to adjoint A into 1 by determinant A, which is 10, and then we need to multiply it with B, which is 4, 0 and 2. So when I multiply them, we get 2 minus 1 and 1. So please do multiply. So we get 16 plus 0 plus 4. So 16 plus 4 is 20 by 10 is 2. Okay. So multiply the two matrices, divide by 10, we get the value of x, y, z as 2, minus 1 and 1. So problem 13 is given here. So let's try to find the value of determinant of A. So we have 2, 3, 3, 1 minus 2, 1, 3 minus 1 minus 2. So we get 10 plus 15 plus 15, which is 40. So determinant A is 40. So let's try to find the cofactors. So A11 of course is 5. A12 is minus of this, which is 5 again. And A13 is again 5. Next A21 is leaving the second row and the first column. So we get 2 into so A21 is minus 6 plus 3 with a minus sign, which is plus 3. Then A22 is, we have minus 4 minus 9. So minus 4 minus 9 is minus 13. And then A23 is, A23 is 2 into minus 1 is minus 2 minus 9. So minus 2 minus 9 is minus 11 with a minus sign, which gives me plus 11. Next A31, 3 into 1 is 3 plus 6. So 3 plus 6 is 9. Next A32 is 2 into 1 minus 3. So 2 into 1 is 2, minus 3 is minus 1 with a minus sign. So and A33 is minus 4 minus 3. So minus 4 minus 3 is minus 7. Okay. So we have x, y, z equals 1 by determinant A, adjoint A into B, matrix B. So we have 1 by 40 into adjoint of matrix A is 5, 5, 5. So writing them column wise. So then we have 3 minus 13, 11, 9, 1 minus 7 into B, which is 5 minus 4 and 3. So what do we get? So when I multiply them, so multiplying the first row with the first column, we get 40, then we get 80, and then minus 40 divided by 1 by 40. So that gives me 1, 2 and minus 1. Right? So x, y, z is 1, 2 and minus 1. So please make sure that you multiply the matrices and then calculate the values. So next, problem 14. X minus y plus 2z equals 7. 3x plus 4y minus 5z equals minus 5. 2x minus 5 plus 3z equals 12. So let's first find the determinant. So we have 1 minus 1, 2, 3, 4 minus 5, 2 minus 1, 3. So this is determinant A. So this is equal to 1 into 4 into 3 is 12 minus 5. Minus of minus 1, which is plus 1, 9 plus 10. So this is 3 into 3. Minus of minus is plus 10. Then we have plus 2 into minus 3 minus 8, which is minus 11. So we get 7 plus 19 minus 22, which gives me 4. So this is determinant A. So next let's find the cofactors. A11 equals, so let me write the polarities plus minus plus, minus plus minus, plus minus plus. So A11 equals 7. Next A12 is actually 19 with a minus sign here, so that gives me minus 19. A13 equals minus 11, which is calculated. Then A21 is minus 3 plus 2. Minus 3 plus 2 is minus 1 with of course a minus sign, which gives me 1. Next A22 is 3 minus 4. So 3 minus 4 is minus 1. Next A23 is minus 1 plus 2, which is plus 1 with a minus sign, so I get minus 1. Next A31 is 5 minus 8, which is minus 3. Next A32 is minus 5 minus 6. So minus 5 minus 6 is minus 11. Of course with a negative sign here, so we get plus 11. Next A33 is 4 plus 3, which is 7. So we get 7 here. So therefore x, y, z equals, so I have 1 by determinant A, which is 1 by 4. Next, writing the cofactors column wise, I get 7 minus 19 minus 11. Then I have 1 minus 1 minus 1. Then we have minus 3, 11, 7 into B, which is 7 minus 5 and 12. Okay, so when I multiply these two matrices, I get 1 by 4 into 8, 4, 12, which gives me 2, 1, 3. So the value of x is 2, value of y is 1, and value of z is 3. So in problem 15, we have matrix A and matrix B. So matrix A and matrix B can be written as a system of equations defined by Ax equal to B, wherein we have 2x minus 3y plus 5z equals 11, then 3x plus 2y minus 4z equals minus 5, then x plus y minus 2z equals minus 3. So those are the three equations what we get. So the first question which has been asked in the problem is, are the system of equations consistent? So to find whether the system of equations Ax equal to B is consistent, we need to find the value of the determinant. So find determinant A, which is 2 into minus 4 plus 4, then plus 3 into minus 6 plus 4, then plus 5 into 3 minus 2. So this is 0 here, so I get minus 6. So this is 0, so here we get minus 2 into 3, which is minus 6, plus 5 equal to minus 1. So determinant A equals minus 1, so therefore the system is consistent. So now since the system is consistent, we need to find the values of x, y and z. So how do we find the values of x, y and z? It's equal to 1 by determinant A, adjoint A into B. So to find the adjoint of A, let's find the cofactors. A11 is 0. Next, A12 is minus 2 with a minus sign, so we have plus 2. Next, A13 is 1. Next, A21. So let me write the signs for easy reference. So we have minus plus minus, plus minus plus. So what is A21? A21 is 6 minus 5, which is minus 1. Next, A22 is minus 4 minus 5. So minus 4 minus 5 is minus 9. Next, A23 is 2 plus 3 is 5 with a minus sign, so I get minus 5. Next, A31 equals 12 minus 10, which is 2. Next, A32 is, we have 4. So A32 is 2 into minus 4, which is minus 8 minus 15. So minus 8 minus 15 is minus 23 with a negative sign, so which is 23. And then A33 is 4 plus 9, so which is 13. So writing all the cofactors column wise. So here of course I have 1 by minus 1, which is the determinant. So I get 0, 2, 1, minus 1, minus 9, minus 5. And then we have 2, then plus 23 and 30. And I need to multiply it with 11, minus 5 and minus 3. Right? So when we do that, we get the answer as minus 1, minus 2, minus 3. So we will get 1, 2 and 3 multiplied with a negative sign. So the value of x, y and z is equal to minus 1, minus 2 and minus 3. So the last problem, we have an interesting one, which states that so problem 16, which states that 4 kgs of onions and then plus 3 kg of wheat plus 2 kg of rice would cost 60 rupees, and then we have 2 kgs of onions plus 4 kgs of wheat plus 6 kgs of rice would cost 90, and then 6 kgs of onions plus 2 kgs of wheat plus 3 kgs of rice would cost 70. So we need to find the cost of onion, wheat and rice per kg. So this can be written in the form of a matrix. So we have, so let onions be x, wheat be given a variable y and rice be given a variable z. So we can write the coefficients of onions, wheat and rice as 4x plus 3y plus 2z equals 60, and then we have 2x plus 4y plus 6z equals 90, and then we have 6x plus 2y plus 3z equals 70. Okay, so we need to find x, y and z. So let us find determinant A. So this is 4 into, so we get 4 into 3, which is 12, minus 12, minus 3 into, so we get 2 into 3 is 6, 6 minus 36, then we have plus 2 into 2 is 4 minus 24. So that gives us 50. Okay, so now let us find the cofactors. So let me write it as 4, 3, 2, 2, 4, 6, 6, 2 and 3 with their respective signs on top for our reference. So we have plus, minus, plus, minus, plus, minus, plus, minus, plus. So what is A11? So A11 of course is 0. A12 is minus 30 with a minus sign, which gives me plus 30. Next, A13 is minus 20. Next, A21 is 3 minus 4. So 3 into 3 is 9 minus 4, which is 5. So with a minus sign. Next, A22. A22 is 4 into 3 is 12 minus 12, which is 0. Next, A23. So the second row in the third column, 4 into 2 is 8 minus 18, which gives us minus 10 with a negative sign, so we get 10 here. Next, A31. So we have 3 into 6, which is 18 minus 8, which gives us 10. Next, A32 is 4 into 6, which is 24 minus 4. So 24 minus 4 is 20 with a negative sign, minus 20. And A33 is 4 into 4 is 16 minus 6 is 10. Right? So we can find the value of x, y, z, which is 1 by determinant, 1 by 50, adjoint A, writing them column wise, 0, 30, minus 20, minus 5, 0, 10, and then we have 10, minus 20, 10. And then into B, so B happens to be 60, and then 90, and then 70. So we have 1 by 50 into, so I get 0 into 60 minus 5 into 90, which is minus 450, plus 10 into 70 is 700, and then we have 30 into 60 is 1800, plus 0 minus 1400. Next we have minus 1200 plus 900 plus 700, right? So this gives me 250 by 50, right? So 250 by 50, which is 5. Next here we get 400 divided by 50, which is 8. So 900 plus 700 is 1600 minus 1200, which is 400 divided by 50, which is again 8. Right? So therefore the cost of onion per kg is 5 rupees and wheat is 8 and rice is 8. So let's see if, let's substitute the values here and let us check. So we have 4 into x, that is 4 into 5 is 20, plus 3 into 8 is 24, plus 2 into 8 is 16. Is it 60? So 24 plus 16 is 40, plus 20 is 60. So it satisfies the first equation and it would satisfy the other two equations also. right? So in this section, in this lecture session, we have solved all the problems of exercise 4.5, and I hope you found it informative. It is a fairly simple exercise where we need to find the values of x, y and z. So in this lecture session, we have solved all the problems of exercise 4.6. It's a fairly simple exercise where we need to find whether a system of equations are consistent. So to check if the system of equations are consistent, find the determinant. If the determinant is not equal to 0, then it is consistent. If it is equal to 0, we need to check if adjoint of the matrix A into B is equal to 0 or not. If it is not equal to 0, and if determinant A equals 0 and if adjoint A into B is not equal to 0, then the system is inconsistent, right? And the next set of problems includes to find the value of x. So how do we find the value of x? X is equal to A inverse into B, and of course x is equal to adjoint A into B divided by determinant A, right? So by using these two expressions, we can solve all the problems given in this exercise 4.6, right? So the next video segment, we will solve all the miscellaneous problems given for chapter 4. Please make sure that you do like, share and subscribe, and thanks for watching.